Share my screen. All right, so let's go through the homework that was due today, and then we'll keep cooking. Remember, online folks, if you have a question, just unmute yourself and blurt it out, and we'll make sure we address it, because I won't necessarily see you like raise your hand or something like that with one of those buttons. Okay, so assignment for today was to write a program that stores the number of years old you are in a variable and also creates variables for the number of months, days, hours, minutes, and seconds old you are, right? So we're working with variables, we're using some of the division stuff, all that jazz. So let's look at that over here. So we have a variable for number of years, right? Number of years old. We'll really spell it out there, and I'm going to put in my age there. And then we want to have variables for months, days, hours, minutes, and seconds. So for months, we're going to have number of years old times 12, right? That's the number of months. All right. Number of days is number of years old times 365. Some of you might have gone and looked up, what is it? Isn't it 365 days, 5 hours, and some odd number of minutes? I actually think there's like 3 different actual measurements for days in a year, actual time in a year, depending on like our rotation around the sun and things like that. I was watching some documentary on it not that long ago, but something along those lines. Hours. So for hours, we can operate off of days and then multiply it by 24. So hours is equal to our days variable times 24. Minutes, and then seconds. So minutes is equal to hours times 60. Seconds is equal to minutes times 60. And then you can print all of those things out if you want. I'm actually going to go ahead and show you a shortcut from some of those things. It was something you asked at the beginning of last class that you forgot to remind me to actually do, how to link stuff together, have multiple things on one line. But we'll just print these things out. Go ahead.
I ended up using dot format.
Yeah, and I'm going to show you a shorter version of that called an F string today. Print. All right, so this should give us all of our values. So I'm 21 years old, 252 months, 7,665 days, 183,960 hours. So a bigger number for minutes, and then an even bigger number for seconds. All right, so now let me show you a shorthand for this. There's various things. Well, first of all, any questions about that? That would kind of do it for the homework. I guess technically you didn't have to print it, but you probably should have to make sure that your numbers were correct. But you know, the idea here is we created a whole bunch of variables using memory, all right? And we made these guys in terms of each other and kind of got all the right math. Go ahead.
What if instead of typing numbers years old equals 21, all that, what is what print and 21?
So you just hard coded the values?
Yeah.
So you did the math externally?
What?
You did the math outside of the program?
Yeah, what if you did it that way? Would that count?
Well, I mean, I probably gave you some points, but why wouldn't you use the program to do the math? If one of the things we're trying to do is solve problems that we would do in real life, and we're writing computer programs to do those things, probably want to use our code to actually do the math. And what's up?
To make it easier.
But it's not easier.
Yeah, it is.
What if I go and change the age to 48?
So I'm not saying that particular. I'm saying like here,
Oh, right. Yeah. So I mean, but there's the reason.
Yeah.
So doing it the way you suggested, the second you change age in a number of years, now you have to go and redo all those other calculations, or I just have to run this thing again. And now it's got the updated stuff for number of years old. Well, for that new value. So that's the advantage of using variables, placeholders for things, because then you can define them in terms of each other. And now I can just update one place and all the rest of the math just works out. Because I've created the generic representation, the solution for doing all these things. Make sense?
Yeah.
All right, so let me show you a couple of things we can do here. And I think it's probably in the slides, but I'm going to talk about it here. Then if we bump into it in the slides, we'll skip past it. We have this thing called concatenation, where you can glue strings together. So for instance, I can say print hello concatenated with a space concatenated with world. And this will attach all these strings to each other, building a single string, hello space world. So there's that single string. So this guy here is called, this is the concatenation operator. Okay, we also recognize that as the plus sign for doing math, right? So the question is if you are Python and you're trying to figure out, is this guy, so you put yourself in the role of the Python interpreter and you come across this operator, you say, oh, wait a minute, that guy has multiple meanings. Which one of those meanings is this guy? What rules is Python following for that? Well, Python's going to say, well, this is the addition operator if the values on either side are numeric. This is the concatenation operator if the values on either side are string-based. Okay? So because this guy is a string and this guy is a string, and Python does require both sides to be strings. I'll give you that as an example here. So for instance, if I was using a language like Java and I said hello plus 5 like that, it would work. Java would give me the string hello 5. Python screams at me. Python says both of these values, both sides have to be string type. So that's a caveat of Python. If you're doing concatenation in Python, because concatenation pretty much exists in all programming languages. You know, you want to glue strings together, you use concatenation to string them together and build up something. But with Python, it specifically says both sides have to be a string type. So that means if I want to get a 5 tacked onto a string like hello, I need to turn that 5 into a string. Now, if my 5 is stored in a variable that's currently a numeric, and I'll get to you in a second, I can say hello concatenate with the string version of 5. We have several functions that allow us to convert things to other types of things. So this is a function called str, which will take 5 and turn it into the string version of itself. So now I'll have hello concatenated with the string 5, which should give me hello 5. Good. Yeah. So, I mean, I'm just kind of giving some examples here. So, I mean, you could certainly like do that and then take this middle part out. You know, I'm just showing you some examples of gluing these things together. Better examples might be something like this. So I might say S is equal to hello. S2 is equal to world. Number is equal to 5, something like that. If I want to print out S concatenated with S2, that will work, but it's going to mash hello and world together. I have two different variables. I want to get those guys mashed together. So there's my hello world. But if I want a space in there, I can insert the string literal space. And now it'll take S, glue onto it a space, glue onto it whatever S2 is. So this is a better example because we don't necessarily know what's in those variables. Variables resolve to their value. So this is whatever S is. S is the string hello. This is whatever S2 is. S2 is the string world. So if I run it right now, I get hello world. But if I change hello up here to elephant, I don't have to change any of the other code. Now I'll get elephant world, which should be the name of the next Disney movie. I don't know. Doesn't it seem like it? It'd make money.
I already have one called Dumbo, right?
Yeah, I didn't see it. Was it any good?
I didn't see the new one, but I remember watching it.
Go ahead.
So on mine, like, I was like doing like the print thing, and I just said like, okay, I'm 18, and then this means like I'm like this many like weeks, whatever. And I did so in order to put the variables, and I did like the commas. So I had like the variable name, and then I surrounded it by commas. How is that different from like?
Not commas, curly braces, right?
I don't know what the commas.
Okay, well, I'm going to show you here in a second. We're going to do an F string, which is a formatted string, but maybe the hard-coded version of this might be my age in seconds is something like that. I'm going to concatenate it with the string version of whatever seconds is. And that'll get me my age in seconds is this guy. But we can do something called an F string, a formatted string. Now, punchline is there's a bunch of different ways of accomplishing some of these things because there's actually a formats function for print that is the longer hand version of what we're about to do here. So I'm going to create something called an F string. F strings, you put a little F before it, and then it's opening and closing string. So this is like a special version of a string. It says, treat this string as a formatted string. So now I can put placeholders in here. So I can say years. I'll just put some placeholders in here, and months, days. We'll just leave it at those three for right now. And then for years, I'll put in number of years old inside those curly braces. These are placeholders that we want to insert that string. For months, we'll put in months. For days, we'll put in days. All right, so it's going to say whatever is inside of this opening and closing curly brace, that guy is a variable. I'm going to resolve that variable to its value. And now when I run this, you see we get years 48, months 576, days like that. Now, if I want these guys to be on different lines, I can put the line feed character in here. So that says, historically it would have been \r\n. That is carriage return, then a line feed. Today, pretty much all editors treat \n as the carriage return and line feed. So it's equivalent to pressing return on the keyboard. So that's something that won't show up on the screen, but does have a function. It'll kick it down. So there's my years, months, so on and so forth. If you want to have it all left justified, just make sure you don't have spaces after the end. But these are all formatting type things. So I mean, you know, you could say it's important to be able to do that kind of stuff, but this really isn't a logic problem. This is more of a, you know, making your output look nice type situation. All right, so questions about concatenation, formatted strings, things like that. We'll come up with some other alternatives to these things as we go, but I use formatted strings pretty often. It's a nice, clean way of accomplishing it. Go ahead.
Because I was looking at code on the internet, and I was trying to do just that with the curly braces, but because it wasn't a, what do you call it, an F string,
Yeah,
Because I
yeah,
didn't make it an F string that didn't
yeah.
work.
If I don't put an F string in front of it, that's the whole magic. Now it breaks. By making it an F string, I'm telling Python, treat this guy special. Process him through some other mechanism for replacing things that are inside those curly braces with the values of those variables. So maybe this is kind of evidence. And, you said you had a format that, you had commas or something. Here, help me type it. So give me.
I basically just like, so there would be like text just for like hello.
Okay.
And then do like, yep, and then do a comma, and then do like one of your variables. Like,
Oh, yeah. So like S, something like that. Yeah, so what this is based off of the C printf statement. So it just inserts. One thing you'll see on some other online things is you can say, I think it's end L equals space like this. And then if I say print S2 on this next line, is it not end L? Maybe it's just end. Yeah. So by default, when you say print, there's a default thing here, \n. It automatically kicks it down the line, the normal print. If you want to suppress that, you can put a little end is equal to the empty string here, which basically says, instead of having the end of my line automatically press enter and kick it down, this will leave me on that same line that gave me hello. And then the very next line, that S2, was printed on the same line as it. So kind of the punchline here is with Python, as well as most programming languages, there might be a bunch of different ways of handling things. In fact, I would say Python is worse about that than most languages. Languages are and actually it's probably a truth of most of our interpreted, loosely typed languages, because those languages are so much easier to create. They might give 9 different ways of accomplishing the same thing. And then sometimes then you have, okay, well, all these work, they basically do the same thing. You kind of pick the one that you like the best. I tend to use F strings, but these are all different ways of accomplishing the same task, which is fine. There's nothing really wrong with that. But from a programming perspective, from a, learning a language and then being able to wield the language like a weapon, I like things to be a little bit more logical, where we have like, this is how you do this. This is how you do this. So I think some of our native languages like C, C++, Java give you some less choices. The worst culprit of this, I think we had a picture of it in our, somewhere here, we had the history of our languages, is this dude down here, Swift. At some point we're going through here, I don't know if we ever talked about Swift, but these two, so C is the kind of the, let's call it the parent of all the modern languages. Wasn't the first programming language, but it's a very important ancestor of all of our modern languages. That little formatted string thing there's a function in C called printf that accomplishes that same thing. So all these other guys kind of stole from it. Go ahead.
When you do the case where you use the print and then comma and then the variable, can you not write anything else in a string after that variable?
Yeah, I think you're done with your string at that point. Yeah. So then C++ was the object-oriented version of that. Java was the better object-oriented version of C++. I would usually kind of say that Java made a lot of decisions for a programmer to protect a programmer from themselves. C++ empowers the programmer to make bad decisions from a memory efficiency perspective. The example I might use is, let's say you're having a party at your house tonight, which is bad news during COVID. Apparently, people are getting kicked out of universities and stuff, so don't do that. So you're going to have a party last year at your house, and you're inviting me to it. Do you give me the address where your house is, or do you hand me the house? Which is the right thing to do? Yeah, you don't hand me a house. Houses are heavy, right? You give me the address. You say, look, write a little piece of paper, send a text message, whatever. You can go to this place in memory, this place in the world, following this address and get to my house. That's a nice convenient way of you letting me know what location I should arrive at. Computer memory works the same way. finding, and in fact, it works simpler, but it's more intimidating because we just see it as a crazy hexadecimal value, you know, because in real life, we have a whole bunch of different parts to our addresses, right? You know, you have street number, you have street name, you have city, state, zip, you know, all these things that ultimately zeroes this in to the right place in the world. Okay, with computers, all the houses are in one big long line. This is house 1, this is house 2, this is house 3, this is house 4, that's house BAD 2989. So then you start getting these really giant numbers that look really scary because they're written in hexadecimal, but all they are is telling you which house number to go to. But if we take the idea in real life, if you were inviting me to a party, you would give me the address where your house is, not the house. C++ empowered the programmer to let you give the house. As the programmer, you got to choose. You could say, look, I'm going to tell you where you can find the house, or I can give you the house. Now, we would say that never makes sense. Realistically, in programming, sometimes, every now and then, you might want to do something that doesn't make sense in real life, but maybe allows you to accomplish something in the language. But until you're a skilled programmer, you maybe would accidentally pass the house, which now makes your programs horribly memory inefficient. Java takes those decisions out of the programmer's hands, which now keeps you from doing some things that maybe once in a million, it you know, they were useful, right? But it now prevents you from being able to do those things, but it also protects you from doing stupid things. One thing I don't like about Java, we'll see this next semester, because I'll show you how to do something in Java, and then I'll show you the older way of doing it. And you'll see how much Java hides from you. Java does a lot of what I call syntactic sugar. You know, things just magically work because it skips 3 steps that you used to have to write, but since you should have always written the same 3 lines, they just make you write 1 line now. All right, but we're going to call Java the upgrade to C++. Then Microsoft tried to steal Java, got sued. They came out with C#, which was Java, with their own syntax, but this is fine. I mean, C# brought some innovation to this world. So it started off as a copycat after they got sued, but these are both, you know, compelling languages. You're going to find high-paying jobs with both of those languages today, as well as still some C and C++. Over here, this is the Macintosh, the Apple languages. So Objective-C, this was the early days of object-oriented programming. So Microsoft went the C++ route. Apple went any direction that Microsoft wasn't going because they were enemies. So they chose to get onto this project called Objective-C, the object-oriented version of C. All right. And then they had Objective-C 2.0 in here somewhere. This is a very kind of archaic language. It's actually one of my favorite languages. I'll show you some examples in it once we get into some object-oriented. It has a very different syntax. But once you get into it, you realize it's just like any other language, just the syntax looks a little bit different. But in any case, I really like Objective-C. And when I first started writing iPhone software, the way you wrote iPhone software was with Objective-C. So that language became much, much, much more popular. Because you imagine there's probably far more people writing programs for iPhone than are writing programs for the Mac. You know, if you were a Mac developer, you probably thought, oh, everybody writes software for the Mac, but that's not the truth. If you're a gamer, you get a Windows machine because that's what the software is released for, right? All right, so if you're a programmer, historically, let's call it, we'll be nice. We'll say 95% of the software comes out for Windows. 1% comes out for Macintosh only. The other 4% might come out for both. But generally, everything comes out for Windows that means anything. So these languages, like Objective-C, these were really only used by the Apple developers, people who were writing software for the Mac, which represented a very small percentage of developers. But iPhone got pretty popular, right? More people carry iPhones than carry Macs. Now, Apple's probably as popular today, probably more popular today than it's historically ever been. You know, you see people with Mac laptops all over the place and stuff like that. They've kind of dropped the price point to a point where people, you know, don't have to choose between eating and having a laptop, but they're still expensive. But the punchline is that as a brand, Apple's probably more popular today, and that's been driven by things like iPod and iPad and iPhone, and you know, people want to be in that ecosystem. but still it's far, far, far less popular in terms of install base than Windows, right? Apple used to have 99% of the desktop operating system installs, and now it has 94% or something like that. So if you're an Objective-C developer, you know, you're in a niche, right? Well, then Apple came out with Swift. I promise you, if you were an Apple developer, you were one of these guys, you weren't complaining about Objective-C. I loved Objective-C, it was great. I was writing my iPhone apps in it, it was really popular. It almost seemed like a superpower because a lot of people didn't know it because it was kind of a cryptic language to initially learn. But then they released Swift, which is the newest of these native languages over here, because I've kind of advertised that compiled languages are a little bit, they're complex. We don't get new compiled languages every 5 minutes. But they came out with Swift. But the funny thing here is that these people over here were not complaining. They're perfectly happy with Objective-C. Why do you think Apple came out with Swift? Go ahead. Okay. I think that's mostly right. Let's go a little bit more nefarious with it. If you're writing Android applications, so Apple's competitor, so you can write iOS apps, you can write Android apps. If you're writing for Android, you're using Java. If you're writing for iOS, you were using Objective-C. Swift looks shockingly similar to Java. It also looks shockingly similar to Python, to these languages that are over here, the web programmers. So the reason I brought up Swift in this case is we were just looking at an example with Python where there's like 20 different ways of accomplishing the same thing. Swift is similar to that. They've brought in things from all these different languages that people are already coding in and said, hey, this is a nice comfort zone for you. You used to do it this way, you can still do it that way. You used to do it this other way, you can still do it this other way. You can name variables with emojis. That doesn't make any sense. It's not cool. Variables, just like we've written here, should have, well, not just a purpose. You should spell out what these variables mean, right? When you name a variable, that variable has, the name of it itself has meaning. I'm not sure we quite are at the point now where emojis have the level of detail of meaning that you can accomplish with words. You know, I get that some of them you can kind of put together the idea with some emojis and stuff like that, but I mean, effectively, we're like going back to hieroglyphics. It's like we're going, it's like full circle. Sometime in the future, somebody's going to have some printout with a bunch of emojis on it, and they're going to be sitting there like trying to figure out, well, what does this mean? That's what it is with color. But Swift to let you put hieroglyphics. That sounds better to say hieroglyphics. We call them emojis. That makes it's a friendly version of hieroglyphics. And actually, my keyboard, my Mac here has like this this multimedia bar thing here at the top. So if I type in words, sometimes it'll give me an icon for it. So like one of the examples we'll eventually get to, I teach you this sorting algorithm where we have this variable that I call the follower, and I always say it like it's called the follower, and I make it a skull because the skull will follow you, right? Yeah, that's good uses for emojis. And that whole Animoji thing on iPhone, I don't get that. The Animojis, where you like it takes your face and now your face can be like a puppy or something like that, where it matches your facial expressions. I know that's that's where we're going. I'm not keeping up with the social media stuff. For me, cool social media is Facebook. Yes, he was like, that's what was the cool kids. So in any case, with Swift, they tried to be everything to everyone, but the real goal here was, hey, Android developers, come over to the dark side and write stuff for iPhone. Hey, web developers, come over to the dark side and write stuff for iPhone. So they gave them a language that would be intriguing to them, seem like, hey, it's new, we're going to try it out. It's not this old archaic language that maybe is a little bit more difficult to learn. Bring people over to the dark side. Because I promise you, these folks over here were not complaining about Objective-C. Perfectly happy with it. In fact, many of them complained about Swift. Like, why do I have to change? Why can I name my variables with emojis? Just dumb. All right. But in any case, that's kind of our history of our languages there. But the reason I came back to this was this idea that Swift gives you a bunch of different ways of accomplishing the same things. I wouldn't get too pulled into that. I've been programming, for example, in Java since the day it was released, which was in the 1990s. And I probably know 10% of the total language. You know, there's all this stuff in the language that allows you to accomplish all sorts of different problems. And I've only worked with the things for the problems I've tried to solve, which isn't every single security problem or something like that that it has tools built in for. So the idea is that you never learn the full language, just like with English. You know, you can go through the dictionary and find plenty of words you haven't heard of, or you don't know how to use or whatever, but you know, you have a fluency in it because you have your collection of words that you build your communication out of. All right, so let's get. All right, so anyways, we have some ability to do some formatting stuff like that now. All right, so now we want to start talking about collections in Python. Up to this point, we've had the ability to hold single values, right? Like the number 5, the number 7. We can have like the character C. So if I come down here and I say, you know, I'll call this guy, I'll create a variable called a letter, and I'm going to make this equal to C. I'll create a variable called a number, we'll set this equal to 5. All right, so these are examples of the types that are built into, we can say a Boolean, and this guy is going to be equal to true. Is it true like that, or is it true like that? There we go, it's capital T. Go ahead.
Is a float versus an integer a different type?
It is.
Okay.
Yeah, so, you know, we can call this an integer. We can call this guy a float. Something like that. But these are types built into the language, are primitive types that are part of the Python language. Now, these guys, all they can do is hold a value. We need other things to operate on them. We do have something, though, called a collection, and we've already seen these. So we have something like a string is equal to hello. A string is a collection of characters. Make sense? And we can go through a collection. I can say for each char, I'll name my variable, each char, in a string, print the char. So this is a variable name. You can call it whatever you want. So you know, a lot of times I might say like for C in a string, print out C. So the first time through, C will be the first character. And then the next time it'll be the next character. Next time it'll be the next character, next character, next character. So this will be hello, 1 character per line, because print automatically puts a carriage return at the end of each line, right? There's my hello, 1 character per line. But if I wanted to not put a carriage return each time, I could say end is equal to the empty string, and now it'll put them all right next to each other. Stupid formatting stuff, right? It's not logic, that's just what it looks like when it comes out. But the piece that's interesting to us right here is that this for each loop, this allows us to go through the collection of characters that are in string. And we've also already seen another way of generating collections. So I can say for I in range 0 to 10, print out I. This will print out a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, because 10 is non-inclusive. So there's your 0. Notice that 0's up here. It's up there because the end of my last line for O still did not press enter on the carriage return. So when I print HELLO up here, I left my cursor right here at the end of that word And that's where it was when it printed out the 0. And then it kicked the 1 down because I didn't modify my print here for that. That make sense? So again, a formatting thing. If I take this guy out, they'll all be on one line. All right, so range creates for me a collection of numbers between 0 and 9 inclusive, so not including 10. And then I'm going to go through every value in that collection using I to be a placeholder, a temporary placeholder for each of those values each time through. All right, but now what if we want to make our own collections? So this is a collection generator. This is a collection that already exists. So what if I wanted to say a list is equal to, and I'm going to use the opening and closing square brackets. This is how we specify lists. Go ahead. In Python, they're called lists. Effectively, these are arrays in other languages, but they're called lists. But punchline here is that languages that call them arrays use this opening and closing square bracket. All right, so I'll put in like a 1, a 3, a 6, a 5, a 2, something like that. So comma separating them inside of the opening and closing square brackets. I can do for I in a list, print I. So this will print out a 1, then a 3, then a 6, then a 5, then a 2. It'll go through every element of that collection, printing a value. One, 3, 6, 5, 2. Go ahead.
What if you just wanted to print like the whole number? So like
Yep. So if I only wanted, so there's 0 index. So this is the value at bucket 0, value at bucket 1, bucket 2, bucket 3, bucket 4. So if I wanted to print this last guy there, I could say print a list at bucket 4. And that will allow me to extract the one value that was the last value. I can do the same thing with strings. I can say print a string at bucket, let's just do this first L, 0, 1, 2. So that'll print out that L. Make some sense? All right. Now, we also have a function called length. Well, it's called len, that will give us the length of a collection. So I can say print the length of a list. And this guy should have a length of 5. I can say print the length of a string, which is hello, which also has a length of 5. Now, this length function requires anything that is a collection. So I'm going to kind of trick you a little bit here, but I'm going to ask the same question. So what is a list? What kind of animal is a list? What is a list? What kind of animal is a list? If you saw a list walking around in the room and you pointed at it, you said, oh, look, there's a, here's where it's defined. What's a list? Okay. What you just did is you resolved it inside your head, right? A list is a variable. A list is a variable that you then resolve down to its value, which is a list. So ultimately, this guy right here will become the value that is stored inside that variable, which is a list. This guy right here, a string, that is a variable, which will resolve to its value, which is a string. So nothing keeps me from saying print the length of elephant. I don't have to put variables in there. I can give you a string literal like elephant and get an 8 out of this because this length function works on collections. these variables boil down to their values. The value happened to be a collection. Make some sense? So there's my 8 for that one. Now the legal values inside of a collection are bucket 0 to the length of that collection minus 1. So this guy has a length of 5. The legal buckets are 0, 1, 2, 3, and 4. So I can, go ahead.
What does the I stand for again? When you put for I?
It's just a variable.
Yeah,
I could change it to LOL if I want. So this guy will be the variable that holds each element from this collection.
all right, I got it.
Yep. It just happens to be kind of a throwaway variable, so I is a common thing to use, but it's just whatever variable name you pick here, that's how you're going to refer to it in your code beneath. All right, so now, when I went through every element of S, or A string up here, I used the for each loop. I can do this, I can accomplish the same thing differently. I can say for I in range 0 to the length of a string. So this is going to take I on a voyage. First time it'll be a 0, then it'll be a 1, then it'll be a 2, then it'll be a 3, then it'll be a 4. The length of a string is a variable whose value is hello. Its length is 5. Range goes from this value inclusive to this value exclusive. So that guy is a 5, so this is only going to go up to a 4. 0 to 4 happens to be the legal buckets in a string. So now I can say I'm going to print. Now if I print out I, this is going to print out a 0, a 1, a 2, a 3, a 4. But I can also print out a string at bucket I. This allows me to use that variable I to get a particular character at a particular place in that collection. Make sense? All right, so this loop takes I on a journey between 0, 1, 2, 3, and 4 in this case. I can use that variable directly and say, okay, well, I counted to 4 in a weird way. Or I can utilize that value to index something. Get rid of the extra stuff down here. So now we'll see, here's the contents. So the first one here will print out the contents of my string. There's hello up here, HELLO. And then I will print out the value of I, which is 0, then the value of a string at position I, which is the H. Next time up, I'll have a 1. I'll print out a 1, then I'll print out the E, the value at that position, so on and so forth. Make sense? All right. So, questions about collections like that? All right, we've already seen strings, now we have lists. We're going to be introduced to a third kind of collection called a dictionary soon, but not yet. So right now we can hold collections of chars by themselves, but I can also hold, so I can create a list of chars, and I can make this guy equal H, E, L, L, O. And now these two guys hold the same collection of things, but if I print out a list of chars versus print out a string, I get two different types of outputs. We know that a string is a collection. Okay? We see it, it's a collection. But we also, it's treated as a string. So right here, a string, that guy is a variable whose value is a string. And the print function, when applied to a string, knows to print the contents of that string to the screen. Okay? Print a list of chars. A list of chars is a variable. What do we do with these variables? Well, variables get resolved to their value. The value of a list of chars is this guy. Make sense? Okay. So we have collections. We have strings. We have the length function. So I give you code examples for all these in there. We have accessing elements of a string. You have code examples of that in there as well. String concatenation. We've looked at that today. Let's see, other string functions. So we can go and look at other functions that are in strings. We're going to look at a couple of them here in a second, but you can go and look at the entire Python documentation. Like I mentioned, you know, there's a whole bunch of stuff that are built into programming languages, some of which you may never use because they might solve some very small, weird problem, something like that. But, you know, at the end of the day, they're out there, they're documented, you can go and look them up, but you're probably not going to use a lot of them on a daily basis. All right, so I'm going to be introducing things that we're going to be commonly using. All right, we've already looked at string formatting here, so I give you some examples of those things. Here's an F string, that kind of stuff. Go ahead.
Sorry, I did the like the print a list of chars and the bucket to print the 0 values to 8, and it printed 4 or 5 8s.
Well, you probably have it inside of your loop. That loop, your loop goes through 5 times.
Oh.
So you're printing bucket 0 5 times.
Okay. Okay, thank you.
All right, so there's your string formatting with some code examples. All right, so now let's look at a function called find. All right, so the find function returns for us the first position of a character in a string. Really, it's in a collection, I believe. No, it is a string. So let me go, we'll just have a string. And I'll go ahead and I'm going to say, well, I'm going to store in a variable. Location is equal to a string dot find an E. And then I'll print out location. Now, the thing you want to think about here is that we're looking at a lot of different ways of storing values. Now we're looking at ways we can operate on those values. All right, think of this like a real life Home Depot type situation, right? We build houses out of wood, for example. That's our values that we're operating on. But then we go to Home Depot and we get a bunch of tools that allow us to do things to pieces of wood. Cut them. We join them together with nails, things like that, right? So what we're being introduced here, this find, is like a tool that you might buy off the shelf at Home Depot that we can now use to work with strings. Okay, make sense? All right, so this find function, this tool, is used with a string. So a string calls the find function, and then the find function requires you to say, what am I looking for? I'm telling this string, I want to look for the first occurrence of the character E in this string. And E is at bucket 1, right? This is bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. The length of this string is a 5. So the legal buckets are 0 to its length minus 1. And we see here that I get a 1. I found an E at bucket 1. Go ahead.
Is there a way to have it, like if you're doing L, have it find the second L in the variable?
You'd be not with find directly. Actually, find might have a version that takes a second parameter to say search from the end. But the default find that we're looking at is returns the first occurrence. So if I put in L, even though there's 2 L's, it's going to give me this 2. Now I could write my own code that walks that string backwards and gives me the location of the last occurrence of L. So we can say, oh, well, this tool does one thing. And I only, like we got the cheap version of find. I suspect find probably has a couple of versions and maybe it does some extra things, but I can go ahead and say, well, what I really want is I want the last occurrence of L. So I can just create a variable, maybe cur location. We'll start this guy off at -1 because I haven't found anything yet. I'll say for, and then let's just do a char to search for. And in this case, we're going to look for an L. All right, and then we'll go ahead and say for I in range 0 to the length of a string. So I'll go through all the characters in there, and I'm looking for the last place that I find an L. All right, so I'll ask if the current place I'm looking at, if a string at bucket I, if the current character I'm looking at is equal to the char I'm searching for. If that's a true statement, what will I do? I'll keep track of the current location, which is I. So I'm going to go through this entire string. Each time through, I'll ask the question, am I currently looking at the character I'm searching for? If I am, I'll record that. So we'll find the first L, but then the very next pass through, we're going to find the next L. And we'll update cur loc to be the next L. So then in the end, we can print out cur loc, which will give us, so up here, when I say find an L, it's going to give us a 2. This one's going to give us the 3. Because I've written some logic that will go through and give me the position of the last place I found that L. Make sense? And this is really a good example because sometimes you might not be able to find the tool you're exactly looking for at Home Depot, but that doesn't mean you can't kind of slap something together at home that lets you solve the problem you want to solve. Now, like I said, there might be a version of find that allows us to do this, but this is pretty simple code to just write. And this is going to be difficult for most of you right now. So hopefully once you see it and kind of walk through it, this makes sense to you, but I don't necessarily expect you to just sit down and slap that out at this point. You need a lot more reps in, because remember, programming is hard. You need to put the practice in. Yeah.
I linked out cur loc equals -1, and the code still works. So did we not really need the -1?
Well, yeah, we did. What if so let's say I'm looking for a X up here. What bucket is X in? None. Find returns a -1 if it can't find it. So what if I'm looking for an X down here? The reason I set it to -1 is this guy will give me a -1. The last place I found an X in there is no place. So this behaves like find. So the find function, the simple tool, says, give me something to search for. I will give you the first place I find it in the string, or I'll give you a -1 if I could not locate it. That's what that tool does. Okay? No more, no less. So don't try to put this thing up on some pedestal that, find is this amazing thing. We went to Home Depot, we bought the cheapest thing that we could find that lets us kind of look for something inside of a string. This is how it works. If you need it to solve a problem, use it. If you don't need it, or if it doesn't quite do what you need it to do, don't use it. Okay, this is just one of our problem-solving tools. You want to think about you have a coding toolbox available to you, just like at your house when you need to solve a problem. You might have a toolbox in the garage that has some stuff in it. Well, you might have that person down the street who's, they're a construction worker or something like that, and they have some pretty impressive tools in their garage. They might be able to accomplish some stuff that you can't accomplish with what you have in your garage. So right now, we have a very limited tool set as beginning programmers, right? So we're going to solve all of our problems in terms of those tools. So we got two options. When we need to solve a problem that's out of our wheelhouse, we either need to go buy new tools, learn about new tools, or just say, I'm not quite there yet, so I can't solve those problems yet, right? So I just wrote this code here real quick. We slapped it together real quick. This should be understandable to everybody in here, but I think that most of you would have struggled to just sit down and write that real quick. right? It's a complex-y type thing, but hopefully you see that all hard programs are made up of a bunch of easy parts. Yeah.
That's my last question.
No, ask us. These have been good.
I would like to know if char to search for, if we could put a list in place of the L and search for multiple characters with one.
If you want to write it that way,
Okay.
yeah. I mean, it's our program.
In the bucket,
Yeah, if I want to put a list in here, so you just say, look, I want to, but then we're probably looking at returning a list. You know, if I'm, you know, so if the char to search for, so maybe we call this chars to search for, and maybe you say, I want to look for an E. I also want to look for an L, something like that. Then ultimately what you're expecting, or yeah, you can throw an X in there as well, maybe an X. And ultimately what you're expecting is a list that comes out that returns a 1, a 3, and a -1. So each time through the list, you're going to have to keep track of multiple counters. So I would initially create another list that's the same length of this guy and zero it out. So I would have another list. I would say temp list is equal to the empty list. I'll say for I in chars to search for, say temp lists dot append. Append is what is another tool that we can use to add something onto the end of a list. So I'll add a 0 onto the end of that list. So if I print out temp list here, I'll have a list with 3 zeros in it. Well, I gotta, yeah, this code no longer does what we wanted to do. So there's my list with 3 zeros. So now I have my curloc for this guy, my curloc for this guy, my curloc for this guy. Make sense? So I gave myself my beginning counters. And actually, we probably don't want to append on zeros. We probably want to append on -1s. Because we only want to change those if we found it. If we didn't find it, we want it to be a -1. So I no longer need curloc. In fact, actually, if you want to call this guy curlocs instead of temp list. Those are our curlocs. So we'll go ahead and give myself a list that has the same number of counters in it, same number of positions as this guy had. Now I'll go through every character in my string. So for C in A string, that's what we called it, right? A string, yep. For each of those characters, I want to search for each of the things inside of curloc. So for, we'll call this guy C2 in curlocs. And actually, I want to have the counter. So I'm going to say for I in range 0 to length of curlocs. And then we'll say if the character I'm currently looking at in my string is equivalent to the current character I'm looking at in curlocs. Actually, the current character I'm looking for in chars to search for. Because no, curlocs and chars to search for, we know are the same length as each other. I built it to be the same length, correct? So saying length of curlocs is the same thing as saying length of chars to search for. In this case, it's always going to give me a 3. So I'm going to go through all the buckets in curlocs. And I'll say if the character I'm currently looking at is equal to the character that I'm searching for. If that's true, I'll go ahead and set curlocs at bucket I equal to, I need to up my position. Okay, so before I found I have a -1 there, I need to increase my position. With a for each loop like this, I get my H, I get my E, I get my L, my O, but I don't actually get the counters. So I would probably upgrade this and say a string pause in range 0 to length of A string. And then I'll say A string at bucket A string pause. If the current character I'm looking at in A string pause is equal to the current character I'm looking for here, then I'm going to upgrade curlokes to be the current value of A string pause. So the first time through, I'm looking for an E. Is an H an E? No. Is an E an E? Yes. That was at bucket 1. So I'll change my -1 to a 1 for that first bucket. So I'll go ahead and upgrade that. And that should be it for that guy, curlokes. There's our 1, our 3, and our -1. All right, now I'll throw this out there. I answered the question because it was asked. This is probably a little bit beyond where we should be right now. So I'll leave the code there. You can look at it, but this is probably going to be a little hard for you to follow. There's quite a bit of, this is a loop inside of a loop, and maybe in 3 weeks or so, this might be a little bit cleaner. So if this was intimidating to you, don't feel like, oh my gosh, I'm lost, I need to drop this class. This isn't where we need to be yet. All right, but point is, he asked, can we do this for multiple characters? The answer is we can do whatever we want. We can just write the code for it. So here's the stuff I want to look for. I gave myself a collection of counters, collection of positions. Instead of curloke, I have curlokes. And then I went through every single character for each of the characters in my string. And if I found a match, I updated my curlokes at that position. Okay. And we were able to accomplish the E was found at bucket 1, the last L was found at bucket 3, and we never found an X. So it still had a -1. Because those are the things we were searching for. Make sense? Okay, so we built our own tool. We didn't have it from Home Depot. We couldn't afford it, whatever it is. We built our own tool to do it. So we can accomplish anything we want to accomplish as long as it's solvable by a computer programming language, and more importantly, as long as we can articulate how we did it, right? We had to break down those steps. I want to look for the H. I'm currently looking at an H. I want to say, is that an E? No. Is that an L? No. Is that an X? No. I don't need to do anything. Now I'm looking at an E. Is it an E? Yes. So I'm going to do something. Is it an L? No. Is it an X? No. So I don't need to do anything for those. So on and so forth for every single character in my string. All right. But for us, what we want to understand out of this is that the find function allows us to search for a character inside of a string, and it returns for us the position in that string where that character was first found, or -1 if it was not found. Hint, hint, that -1 part of it is a pretty powerful part, because that allows us to be able to check, does something exist in a set? Okay? And back here, I give a bunch of examples. And notice you could also search for substrings. So even though we've just put characters in here for the most part, you can say, oh, I'm looking for the substring ness. And the substring ness is found at 3. 0, 1, 2, 3. So that's where that substring first starts, is at bucket 3. All right. So this guy is a tool that we can use to search for things in a string. All right, question about that. So we throw that in our toolbox, we kind of remember that we have it, and now if we need to search for something in a string, we're able to use that. All right, another function, another tool. Went to Home Depot, they had one of those package dealies, right? So we got a whole bunch of tools all related to strings. So we got a tool called replace. And replace allows me to replace the occurrences of one string with something else in a list. So if I go back and I say, well, here, we're going to say another string is equal to cat, dog, cat, elephant, cat, something like that. All right, and we'll go ahead and say changed string is equal to another string dot replace cat with horse. So I'm saying take another string and I want him to replace some stuff. What is he going to replace? He's going to replace all occurrences of cat with horse. I'll go ahead and print out another string, and I'll print out change string. We see that this call to replace did not permanently change another string. If I wanted to preserve that replacement, this guy returned a value. So that thing there boiled down to a string that looks like another string, but with all occurrences of cat replaced with horse. So I showed you that another string is unchanged after that, but now I captured that answer inside of another variable here called change string. And when I print that out, we see that we now have those things replaced. Make sense? Now, from the slide, there's also another version of replace that allows me to say how many occurrences I want to replace. So I can say, I actually only want to replace the first occurrence of cat with horse. So now it says, okay, the first time I find cat, I'll go ahead and replace it with horse, but then I won't do any more after that. If that happens to be the tool you need to use to solve a problem. So again, this, you can say, well, when would I use this? Who knows? Sometime when you're solving a problem and you're rooting around your toolbox for a tool that might help you solve that problem, you know, you need to screw a screw in, and it's a, you know, you're like, okay, well, is it a Phillips head or is it a flathead? You get the right kind of screwdriver out, or if you only have a flathead, you just try to make it work in the Phillips head, then you end up stripping it out and you got to get a new screw or get somebody who's one of those things to cut the top of the screw off. But point is that you have this tool in the toolbox now that might help you solve a problem that you're going to try to solve in the future. Now, punchline is I'm going to give you some problems at some point soon that are going to make you use some of these tools. So they're specifically designed to have you have to think about the tools that are in your toolbox and try to solve problems using them. All right, so are we good with this tool? The replace tool? What?
I was just kind of curious why it's a 1 and not like a 0.
Well, because this says how many occurrences do you want to replace? If I change that to a 2, it'll replace the first 2 cats with horse. My feeling is that this version of replace probably isn't going to be that helpful very often. I would think that the normal version that says, look, I want to replace all cats with horse. That seems like something that might be handy sometimes, right? Like here's an example. Let's say, this is a real life example. So when I need to email the entire class, and I'm not using Blackboard, if I go into Banner and I say I want to send an email to everybody in the class, when it opens up in the Macintosh email client, it puts commas between the email addresses instead of semicolons. Well, the Mac email client, Outlook likes commas. The Mac email client wants semicolons between the email addresses. So what I do, what it ends up happening is I get basically one gigantic email address that won't go anywhere, that has a whole bunch of commas in it and not semicolons. So can't I then copy that into my program here and say, replace all commas with semicolons, which will then give me a semicolon delimited list that I just highlight, copy, paste it back into mail, and it figures out all the individual email addresses. So that's using your programming language, a couple lines of code, to solve a quick little problem that you then can use for another program to make your life easier rather than having to go through there and delete a comma, put a semicolon, delete a comma, put a semicolon, and so on and so forth. All right, make some sense? So these are examples of things that you can accomplish with your programming language. All right, so that's this replace function. Okay, we have another function called strip. And what strip does is it will remove spaces. Well, here. So I'll just put a bunch of spaces before hello and a bunch of spaces after hello here. And I'll say result is equal to a string dot strip. And I'm going to strip on spaces, and then I'll print result. And actually, let me say print length of a string, print length of result. See, originally, a string had 18 characters in it because I had all that white space. And what I said here is I want to strip away those white spaces. Anything that's a space, anything that's the character space, I want to strip away from this, giving me a result. So I printed out that result and said, okay, well, that's hello, but can I really tell if those things have been gone? Well, yes, I can, because I printed out the length of that, the result, and it now only has 5 characters in it. What if I put 2 spaces there in the middle of hello? What does that tell you about strip? Strip deals with the ends. It will take stuff off the beginning. It'll take stuff off the end. All right. Nice tool to have. What if you have an email address and sometimes people accidentally put an extra space on the end of it or something like that, you know, for whatever reason? You can just strip it, make that let you know that, okay, the value I have now doesn't have any leading or trailing spaces. It's just the value they typed. If you tried to strip something that didn't have any leading or trailing spaces, so if I take these guys off, I run it again, still works. Notice it did not change the length of it. Look, I checked, everything's good. Make sense? So another tool in your toolbox. All right, homework assignment for Tuesday is this third thing here. I'll put it up on Blackboard. So write a program that asks the user for an amount of money. And I give you here's user input on slide 110 for reading something in from the user. It's pretty straightforward. All right, so write a program that asks the user for an amount of money owed and an amount of money given to the clerk. And it prints to the screen the proper amount of change optimized in dollars, quarters, dimes, nickels, pennies. All right, so you're making change. And just real quick, if I have a number, well, let's see. If I have the string 123 and I add to it a 5, it's going to yell at me and say, oh, this guy is, both sides need to be a string for this to be concatenation. If I say, give me the integer version of that string, because when you read it in, it'll come in as a string. So you can convert a string to a number using the int function, just like you can convert a string to or an int to a string using the str function. So you'll need this function, int, and you'll need the input function, which is on slide, whatever it was, 110, to solve this problem. Questions, comments, concerns, bribes? All right, I'll see everybody on Tuesday. What's up? No, well, I've had joke bribes before. Maybe actually in my early days of teaching, there were a couple of usually football players. I'm not sure that it was a true bribe, but I mean, it seemed like if I were to have bitten, they might have pulled together some cash. Who knows?